Alright, so after you've taken your quiz or test on the formal definition of the derivative, you'll start to learn a lot of shortcuts and rules that will help you take the derivative of pretty much any function. So these next couple of minutes, I guess, I'll be talking about some of the rules that you'll be able to use to easily find the derivative of pretty much any function. So the first rule is that the derivative of a constant, say c, is equal to 0. And the d over dx that I wrote there is just another way of notating finding the derivative. So the derivative can be notated using either dy dx, which is the derivative with respect to the variable x, or also just using f prime of x, or f prime of t or whatever, which is just the function x's derivative. It's really a matter of preference, but there are certain problems in which you'll definitely feel more inclined to use dy dx over f prime of x, but I guess for now you can easily just choose either or. So yeah, anyway, the derivative of a constant c is 0, so the derivative of 5 is 0, the derivative of 8,000 is 0. So no matter what, because it makes sense, because the slope of a constant doesn't change at all. That's why it's constant. So the rate of change or slope would be 0. And another next rule is called the power rule, and this one is also very helpful, but not as immediately obvious as, say, the constant rule. Like, you'd have to learn this one or do the formal definition a lot to get this pattern. But this is the power rule. So if you have a function of x to the n, the derivative of this function is n x to the n minus 1. So this is just saying if you have a function of a x raised to a certain power and you're trying to take the derivative of it, you just bring that power down and you subtract 1 from the exponent. So I guess we'll do x squared again, because that's what we did for the formal definition example. So the derivative of x squared, using this rule, you bring down the 2, that's your n, this is the x again, and the n minus 1 is 2 minus 1, which is 1. So 2x to the first power is just 2x. So, it also works for other functions, like, say, x to the fourth equals 4x to the cubed, 4x cubed, because, 4, that's the n, and n minus 1, which is 3, is right there. You can try using this also works for negative exponents. So say I have something like d over dx of x to the negative 1. So that would just be negative x to the negative 2. Yeah. Even though the rule is a little bit different, so I recommend you just check out your textbook for the proof of this rule. It's pretty interesting. Anyway, the next rule that you should know is the constant multiple rule, and that's basically just if you have a constant, say c, multiplied by a function u, the derivative of that is just the constant times the derivative of that function. So let's say I'm trying to find the derivative of 7x. So this would be my c, and this would be my u, d over dx. So the derivative of x, which is my u, is 1, but I'm multiplying by 7, so I multiply the derivative of u by the constant 7. So that's just 7. And that also works for other like power rule functions, like I'm doing 4x squared. This is my c, this is my u. So I multiply c, which is 4, by the derivative of u. So the derivative of x squared is 2x. So that's just 8x. The next rule is pretty obvious also, but I feel like it's worth mentioning. This is the sum and difference rule. So if you're trying to take the derivative of a function u plus or minus, it doesn't matter, a function v, that's just the derivative of the first function plus or minus the derivative of the second function. And I guess just to give an example, the derivative of 3x plus 7 equals the derivative of the first function, which is 3, plus the derivative of the second function, which is 0. So that's just 3. So in the next video segment, I'll talk about some more derivative rules.